Noco GB150. One turn on. Plug it to the charge. No light. It shows 700 milliamp in the amp meter. The battery voltage is at 12.5. That's good. 4.1. 4.1. And the last cell 4.1. So the three cells, they have the same voltage. So the battery in a perfect condition. So this Noco which has a fuse here, not a low on resistor. So we check that fuse. The fuse is good. Looks like it's not the switch, because even if we plug the charger, we don't have no light here. When the switch is bad, if you plug the charger, you're going to see the unit is charged. Let's see if there is a 3.3. And we push the power button. Yeah, the 3.3 is not there. And the power button, we should have the VCC, the 11 volt is there. That's good. So 3.3. Okay, so here is 9 volts. And this regulator, we need 9 volt in. Then when we push the power button, it's become 3.3. This is a regulator from 9 volt to 3.3 volt. So we have the 11 volt right here. That's 11 volt. It should go here when it's the power button is pushed to this transistor. Yeah, look. So we have 11 volt right here. In this transistor, there is a 12 volt right here. We have 11 volt here. This 11 volt, when we push the power button, it's go low. That's gonna open this transistor. This is PNP transistor, and this is the gate. And this is the output of the transistor. The output is transistor should go to the 11 volt or 12 volt. This 12 volt right here, it should go right here when we push the power button. So right here we have 12 volt, 11 volt from the power button, and we have here is going to be 0 volt. Shall we push the power button or we? Like if we push the power button, we should have like 10 volt, 12 volt, something like that. That 12 volt is going to go in this one of these diodes. Go to this regulator, the 3.3 from the 12 volt to 3.3 regulator. That 3.3 is going to power the controller. I can see a little burnish in this diode. So we check. So on the diode mode, 0.5. This diode is tested very low. This one is a 0.5. Basically, that's better. So if we flip the probes, 0.3. This one still testing low, so test like a shift. 0.6. Just open. So that low ohm diode, we'll need to remove it first. So let me disconnect the battery.
Okay, that's okay.
We remove the diode, so we test now the other diodes. 0.5. 0.3. 1.2. 0.5. Yeah, this diode again, it is not okay because here is a 0.3, 0.5, and this way is 0.3. So I move it to the side. I move it to the side. Let's go to the microscope. It's kind of hard to see. So I remove that burner diode. So this way you test it open. And if we flip, 0.5. So this diode is good. This transistor. Alright, so we are going to replace the diode and we go. So we'll remove a diode from this port. Same diodes. Is a S16. No, it's still not. The 11 volt is still not going over here. So it means that we need to replace the transistor as well. So maybe it's burned. Yeah, this transistor, which has 12 volt this side, 11 volt here. It's go to low voltage when we press the power button. This 12 volt it should go to this side. Then it should go to the diode. Go to this regulator. Regulator is going to make it 3.3, and it's going to feed the controller IC. So at the moment, this 12 volt, it doesn't go to here when we press the power button. This is a transistor from another board, and let's test it, and we compare it with the one that we have. So this is the gauge, this is the collector, and this is the emitter. So if we put the red here from the base to the emitter, we have no reading. And if we flip, it's read as the transistor. So from the base to the emitter, we have this as a transistor. Then to the collector, the same thing, 0.6, 0.6. If we flip, we have a higher reading, or open. From the emitter to the collector, higher reading. And if we flip, is a higher reading. So in our so the same thing in this one. From the base to the emitter is open, and if we flip, is a 0.6. So this is good. And the other side from the base to the collector is a open. Should be 0.6 here. So the 0.6 should be showing right here as well. So this transistor is good. We're going to remove it and replace it with the other one. Let's replace the transistor, and hopefully the IC is still good. Because after all this, if the IC is bad, we're done. We'll put the black in the base and the red in the emitter, 0.6 to the collector, 0.6. So here we have our good reading. Alright, let's see if the device is going to turn. So still not working, and they did see the smokes coming from the transistor that I replaced. Means still there is some other short. So this diode, 0.2, and 0.2. Yep, the diode is so good. That's the regulator. That's very low. That's very low. Yeah, it's shorted here. This one is short, 3.3 shorted to the ground. You can see it. So I'm gonna need, I should test that regulator at the first. So let's test, see if we still have the short between the output and the ground. No, we don't have the short. You can see it. We have no short. So that's good. Let's install another regulator. Then we install the transistor. So alright, let's do a quick test. 0.6, 0.6, that's good. No lower reading over there. Yep, the diode is still testing. Yeah, no, the diode was testing 0.2 volt because this one was short. So look like it's gonna work now, hopefully. No, it doesn't turn it. Will be the IC is bad now. Yeah, we have 3.3 now, it's good. But the device is not turning now. So it means the controller is bad. It's gonna need to replace the controller. Yep, it's not charging. When it's came to the controller, I will replace the whole board. We did all we can to save this boot, and we did fix the 3.3 volt, and we did see the steps. So next I'm just going to replace the whole board, and we go from there. Yeah, when it's come to the controller, I always just prefer to replace the whole board. So I took the board out and I replaced it with this one from our device that has a dead battery. Turn is on. Is boosting. $12 over there. Flashlight works. Is charging, taking 1.8 amps. So this is all for this video. Thank you for watching, and see you again.